Analytical geometry. Now we have come to our third unit in business maths, and it is analytical geometry. We know geometry is the pictorial representation of lines, curves and shapes. Here in analytical geometry, we are going to give the equations for lines, paths and points. With coordinates, we are going to give equations, we are going to build, we are going to form equations for the paths and for the lines, etc. So, analytical geometry is the study of giving algebraic equations. We are going to write algebraic equations for the points and the lines. Locus. What is the locus? Locus is a path and it is traced by a moving point under specified geometrical conditions. The path of some point is called as locus. The path of some moving point is called as locus. Look at this diagram. Here a circle is there. What is a circle? It is the path of a moving point P. Okay, path of the moving point P with a common distance from the fixed point C. Circle adan ஒரு common point க்கும் ஒரு moving point க்கும் இடையில same distance வச்சு அந்த path ஓட அந்த point ஓட moving path is called as a circle. Okay. So here now the locus of the point P whose distance from the fixed point is constant. Yes, distance between C and P is constant and it is the circle. So here the fixed point C is the center and P1, P2, P3 are the points on the circumference of the circle. And what is the circumference? The moving path, the path of the moving point P is called the circumference of the circle. Now here the point with the locus of the point whose distances from two points A and B are equal. So the point P may lie here, and this line is the movement of the point P, and this point P is having equal distances from the points A and B. So the locus of the point whose distances from two points A and B are equal, okay, if the distance between the point P and A is equal to the distance between point P and B, okay, then the path of the moving point is called as the perpendicular bisector of the line segment. So point P inga up and down move பண்ணும்போது and it is the perpendicular bisector for the line segment A and B. So this is only the locus. The perpendicular bisector is called the locus of the point. First problem. Find the locus of the point which is equidistant from 1, 3 and x-axis. We have to find the locus of some point. I will take the point as P. Okay. And in the diagram, okay, it is the point P and it is equidistant from 1, 3 and x-axis. So the point is having equal distance from this point and from x-axis. Okay, so here it is the point 1, 3. So the distance between the point and 1, 3 is equal to the point and x-axis. Can you tell me what is the measure of this line? What is the measure of this angle? And it is the y coordinate of the point, because this distance between these two is equal to the distance between the origin and the y coordinate. Okay, so this measurement is known as the y1. As we are taking P of x1, y1 be the point, the distance between the point and x axis is equal to its y coordinate. ஏன்னா y இவ்வளோ distance இருக்கும். Okay, so it is y1 and the distance, if we take this point as a, distance between a and p is equal to y1. So ap square is equal to y1 square. Okay, what is ap square? Distance between a and p. So here we have to use the distance formula. What is our distance formula? x1 minus 1 the whole square plus y1 minus 3 the whole square. This is our distance formula, distance between 2 points. So this coordinate is, the coordinate of this point is x1 and y1. So x1 minus 1 the whole square plus y1 minus 3 the whole square is equal to y1 square. Okay, so x1 square minus 2x1 plus 1. Similarly, y1 square minus 6y1 plus 9 is equal to y1 square. Okay, so y1 square we can cancel. So 6y1 plus 10 is equal to 0. x1 square minus 2x1 minus 6y1 plus 10 is equal to 0. If we change the coordinates as x and y, this equation becomes x square minus 2x minus 6y plus 10 is equal to 0. And this is the equation, this is the locus of the point P, okay, which is on our plane. A point moves so that it is always at a distance of 4 units from the point 3 comma minus 2. A point is moving on a plane, we will take it as P. Okay. As usual, from this point 3 comma minus 2, this moving point is having a distance of 4 units. The distance is remaining same of 4 units. Okay. So P be the point and the coordinates of P is x1 and y1. Okay. And A is 3 comma minus 2. So what is given? PA, distance between A and P is equal to 4 units. So PA square is equal to 4 square, that is equal to 16. What is PA? PA is the distance between x1, y1 and 3 comma minus 2. So x1 minus 3 the whole square plus y1 minus of minus, so plus 2 the whole square is equal to 16. While expanding, x1 square minus 6x1 plus 9 plus y1 square plus 4y1 plus 4 is equal to 16. So x1 square plus y1 square minus 6x1 plus 4y1, 9 plus 4 minus 16. 9 plus 4 is 13 minus 16. So it is minus 3 is equal to 0. So the equation of the point or the locus of the point is the locus of the point P is x square plus y square minus 6x plus 4y minus 3 is equal to 0. If the distance of a point 2 comma 1 and 1 comma 2 are in the ratio 2:1, then find the locus of the point. Distance of some point P and between these 2 points 2 comma 1 and 1 comma 2 are in the ratio 2:1. We have to find the locus of that point. So the given points are A is 2 comma 1 and B is 1 comma 2. I take this point as A and this point as B, and P be any point on the locus, and P is x1 comma y1, its coordinates. And it is given that the ratio between the distance of the points is 2:1. The distance of the point P and A is given as PA. We take the distance between P and A as PA and P and B is PB. It is given that the ratio between these two distances, so PA is to PB is equal to 2:1. It is the given point. PA is to PB is equal to 2:1. So, PA by PB is equal to 2/1. So, while cross multiplying, PA is equal to 2PB. So, that implies PA square is equal to 4PB square. So, here also we are using the distance formula. So, distance between P and A. P is x1 and y1 and A is 2, 1. So, x1 minus 2 the whole square plus y1 minus 1 the whole square is equal to 4 into x1 minus 1 the whole square plus y1 minus 2 the whole square. Okay. So, shall we expand this? X1 square minus 4x1 plus 4 plus y1 square minus 2y1 plus 1 is equal to 4 into x1 square minus 2x1 plus 1 y1 square minus 4y1 plus 4. Okay. So, now x1 square minus 4x1 plus y1 square minus 2y1 plus 5 is equal to 4x1 square minus 8x1 plus 4 plus 4y1 square minus 16y1 plus 16. We will bring the terms to the left hand side. So, x1 square minus 4x1 plus y1 square minus 2y1 plus 5 minus 4x1 square plus 8x1 minus 4 minus 4y1 square plus 16y1 minus 16 is equal to 0. So, x1 square here minus 4x1 square. So, minus 3x1 square. What about here y1 square? Minus 4y1 square. So, minus 3y1 square. Here minus 4x1. Here plus 8x1. So, while adding these two it will become 4x1 minus 2y1 plus 16y1. So, it will become plus 14y1 and the constant values here 5 and it is minus 4 and it is minus 16. So, minus 4 and minus 16 it will become minus 20. So, minus 20 plus 5. Minus 20 plus 5. So, while adding it will become minus 15 is equal to 0. So, shall we change the sign? 3x1 square plus 3y1 square minus 4x1 minus 14y1 plus 15 is equal to 0. So, the locus of the point P is 3x square plus 3y square minus 4x minus 14y plus 15 is equal to 0. If A minus 1 and 1, B 2, 3 are two fixed points, then find the locus of the point P so that the area of the triangle APB is 8 square units. So, two fixed points A and B are given. The locus of the point P, so these 3 points P, A and B forms a triangle and the area of the triangle is 8 square units. Okay. So, the area of this triangle PAB or APB is 8 square units. So, let the given point is P, x1 and y1 or its coordinates. The points, the two fixed points are A minus 1 and 1, B 2, 3. Okay. So, it is given that the area of triangle APB is 8 square units, 8 square units. So, here it is the formula to calculate the area of the triangle. Hope you remember this. Half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 8 square units. Okay. So, P, the coordinates of P are x1 and y1 and the points A, I take its coordinates as x2, y2 and the coordinates of B as x3 and y3. Now, we are going to substitute the values in this formula and we have to find the locus of the point, that is half into x1. What is y2? y2 is 1 minus 3 plus x2. x2 is minus 1 and y3 is 3 minus y1 plus what is x3? 2 into y1 minus 1 is equal to 8. Okay. So, half into, we can move this 2 to the opposite side. Okay. So, x1 into minus 2 plus minus 3 plus minus 3 plus y1 plus 2y1 minus 2 is equal to 16 because I move this 2 to the opposite side. So, minus 2x1 plus y1 plus 2y1. So, plus 3y1, here minus 3 and minus 2. So, it is minus 5 and minus 16 is equal to 0. So, plus 2x1 plus 3y1 minus 21 is equal to 0. So, the equation is the locus of the point P is, we will remove the minus, we will multiply the whole equation by so the sign changed in this equation. So, 2x minus 3y plus 21 is equal to 0 is the locus of the point P.